Hello, we're the ambitious aardvarks, and our project was a Braille translator, which we named BrailleBud. So let's meet the ambitious aardvarks. First of all, I'm Alex Zhao, and I'm 15, and I like drawing comics.
I'm Taylor Domicello. I'm 15 and an incoming sophomore.
Calvin couldn't make it today, and I'm also 15.
I believe our other member, Calvin, is at the airport right now, so props to him for joining, but I'm not sure if his audio is quite great, but yeah, he was also a member and I was the instructor.
So why a Braille translator? So we chose to make a Braille translator essentially to provide a more convenient way for people to understand Braille, which is in Braille is a rather uncommon language or a system for most people to know. We believe that this can provide people with a better understanding with Braille and subsequently a better understanding of those who are blind or visually impaired. We also hope BrailleBud can promote education of Braille to the general public. And next we have some statistics. There are 1.3 million people who are legally blind in the US, but fewer than 10% of legally blind people can read Braille, and 10% of only 10% of children are learning Braille. And this is a huge problem because it is statistically shown that someone who's blind but knows Braille has a much higher chance at getting a job, getting employed than a visually impaired person who does not. So Braille literacy is essentially very, very it's a very essential skill for visually impaired people, for them to get that opportunity, I presume.
Okay, let's get into our actual model. So we made a data set that has over 5,000 images of Braille, and they're pretty diverse, but originally we only had one type of Braille. And we noticed that when we tried to put it through our model, it kind of made it harder for any other types of Braille to be recognized since we really only had one specific type. So we wanted to have a stronger model, and so we added more images of Braille with different sizes, like different dot sizes and different types of dots to expand the data set, and augmentations such as rotations, cropping, noise, blur, and brightness to help train our model to be able to better recognize Braille. And we were constantly changing it to help improve the overall accuracy. So we made our model using VIT, and at first it was an 86% accuracy. And obviously we wanted to get it higher because we want most of the users to always have an accurate translation. So first we changed hyperparameters like the batch size and epochs, and realized with too many epochs, it just went up and went down when it came to accuracy. So then we decreased the epochs to the original amount it had and decreased learning rate and increased the batch size. And that's the code for it. Afterwards, we made a confusion matrix just so we can see what the model was getting wrong and why we couldn't increase the learning rate. And it turned out that the letter X was just being completely mistaken for the letter Z, and because it lacked a lot of training data, and we just simply didn't have enough data for capitalization and punctuation since we manually had to put that in. So we fixed those errors and ended up with a 98% accuracy, and the training and validation loss decreased fundamentally, as you can see in the picture right there. This ended up being our final confusion matrix, and as you can see, there's not really a lot of mess ups at all. And using the libraries Matterlib and Seaborn, we made a visual way to see our data. So overall, our model is a classification model that can take individual characters of Braille from an image that a user would upload and translate them into English lettering and display it on the screen for the user to see.
All right, so this part's about letter segmentation. So our model can only identify individual characters or letters. So originally we were going to have AI separate and identify words, letters, and all that, but that didn't work. It gave some goofy results. So what we ended up doing is we worked on a boxing method to identify spaces between characters and spaces between words. And basically, well, actually, we can move on to the next slide. So how we did it is we drew contours along each of the dots of the Braille. And basically, this is our get image is our function along with the code. So basically, we grayscaled the image to make it easier to work with. Blurred the image, detected the contours of each, and then saved the XY coordinates of each contour and each dot to make everything easy. And then we use that for our next little bit. So how we actually ended up classifying the spaces and characters was we sorted the spaces in between the contours. So the shortest spaces would obviously be in between two of the same character or letter. And then the next space would be in between the letters. Then the largest spaces would be in between the words. And then through that, we can pass individual characters and spaces through our model and identify them.
And now for the website and app. So we made some HTML templates which served as our pages, created 5 of them. We initially started with a bootstrap template as a base for our website. These are our templates. I think they're pretty self-explanatory. I think the only notable one is loading, which we couldn't get to work, but we did repurpose it, and it functionally in our website. Routing. So afterwards, we basically routed these templates together to create transition between the pages and the ability to process and display the results of translation. And here's our code with the routing. And after all that, this is our final result. You can upload images. You can result would appear with the translated text. With the translated text, you'll see more of this in the demonstration.
Okay, and I can just quickly talk on Calvin's behalf, but basically, we actually had a little bit of time, not too much, since a lot of the Braille segmentation and the model creation took up a lot of our time. But for the very last day, we had some time to start creating an app using Flutter and Dart for BrailleBud, and it's super cool. It's still in the works, so I'm sure it's going to be finished eventually since our students seem very interested in finishing the app. But for right now, we can kind of show you what we have so far. But before that, we'll get into the demo of the website, which Ulden will also talk about.
All right, it's going to be the demo. So our website's locally hosted for now, and we really only have two, well, not more than two, but 2 main pages, a home page and about page. An about page has all the information. We don't really have to look through all of that. We talked about most of it already. And then there's a little bit about the developers right there. And then you can upload an image of Braille. And then there's a little loading thing. That's the loading thing we can get to work. So we added it there. And there's your image, and there's the translation. Now, if you upload an image of something like a chicken, you get an error because it's obviously a chicken is in fact not Braille, but it's okay. You can go back to uploading normal Braille.
So yeah, and it works for like a lot of different image formats. So like JPEGs and PNGs are the most common one. This one is going to take a little bit of time since it's a pretty big image, but I think it just goes to show that our model can do some pretty big segments of Braille, which we thought was pretty cool. So yeah, there's like a significant amount of characters in there, so it should load soon enough, but hang tight. And there we go. So yeah, that's the translation, and that's just a few images for demo purposes. And I can quickly show you guys the app that we also have started going for us. Okay, so I think originally it was on Calvin's code, since he coded a lot of the app, and as the other group kind of mentioned, Flutter does take a whole lot of time to download and install and all of that. So I think it's really impressive because all of this was basically made just yesterday and it's still in the works. But what we have so far is that if you start running it, it launches the app screen and it will give you an option to take a photo. And this is just like a funky image that is like already displayed on there. But if you like take the photo, the goal is ultimately to pass it into the Python function that we've created that hosts our image segmentation as well as like the machine learning model and run it through the translation system. And then our ultimate goal will be to display the translated text just here. We have that in, but it's not quite implemented yet. So I'm sure it will be implemented eventually. But yeah, that's kind of like the startings of our app. And yeah, that's also, since we just started this like yesterday, it's all pretty much in the works, but I think it's very good progress so far. And our Runway ML video that our students made was also kind of just like a trailer for the whole system, especially a trailer for the app. So we can show you guys that quick.
This is an iPhone, and with it you can read and record almost anything. And
can you guys hear it? Not sure if you can. Okay, perfect.
It's an image. This is an iPhone, and with it you can read and record almost anything. And now, you can even translate Braille with just an image. That's right. With BrailleBud, all you have to do is take one photo and then poof, Braille turns into English. You can use any image you want, and it will have almost a 99% accuracy translating. Whether you want to connect with non-sighted individuals more, or catch on to their plans to take over the world, BrailleBud is for you. Try BrailleBud today. This is an iPhone, and with it you can read and...
Okay, I guess I started playing again. But yeah, that's basically it.